Hello, good morning, ladies and gentlemen. I hope you guys have been doing really great, and I'm really excited after a long time. Here I am with an exciting video on an exciting topic. Um, it is 6 a.m. here. So, as you see on the board, functions. Let me ask you this. What is the function of this spray bottle? Let's analyze. So when you press it with a certain amount of force, when you press the trigger with a certain amount of force, you get water. Like in this case, it's not splashing. You get water with a certain pressure as an output, right? If I press it with a smaller force, you get a smaller pressure. If I press it with a boom, with a larger force, you get it like a rocket, right? So I have an independent variable, which is the force I apply, right? And then the pressure of the water depends on how much force I apply on the trigger, right? So let's relate our topic today. Well, this was to wake you guys up. I know it's early morning, you know. I didn't even have my coffee, but that's fine, you know. Please wake up, guys. So let's keep this right now. So, functions. So today we are going to discuss what exactly are functions. What is the condition to qualify as a function? Like, let's say if we are given an equation with two variables, okay, so on what basis can we conclude or make the conclusion whether or not that is a function or not? And then we're going to see like 2 or 3 examples where we're going to analyze the function graphically, equation graphically, and then we're going to determine whether it is a function or not. So let's begin. Now, a function is a relationship between where an independent and dependent variable, where let's take this as a machine, okay. Let me take the dumbbell example. Remember the adjustable dumbbell? I made an equation relating the weight plates and the total amount of weight. What was the equation? 5x plus 5, correct? That was the equation, right? And then we were putting certain amount of plates on the adjustable dumbbell, and we were getting some output, correct? Right? So our input, the number of 5 pound plates, and then our output was the total weight. Right? Let me erase this to give us some space. Okay, for now I will call it as an equation, not a function, because we still need to analyze what is a function, how do we determine whether we can call as an equation, a relationship, a function or not, right? So I have this y is equal to 5x plus 5, right? Where x was the number of plates and y was the total weight, correct? So let me draw this. So at 0 plates, the weight was 5 pounds, right? And then we had 2 plates with a weight of 15 pounds, right? and then so on, you know. It goes 2 plates, 4 plates, right? So if you guys have not watched my video on linear functions with a practical example, do watch it so you guys know which one I'm talking about. And then for now I'm just this relationship will carry forward, right? If we have 4 plates, so the weight would be 25 pounds, right? That's your total weight, right? Let me write this on the top. So total weight and equation y is equal to 5x plus 5. How can I determine whether this is a function or not? Let's plot the points, you know, just plot like 2 or 3 points to understand. I have 0, 5, and then I have 2 and 15, and then I have 4 and 25, and then so on, you know. It's gonna go like 6 and 35, right? 6, 5 and 30, yeah, 35. The only reason I'm increasing x by 2 at a time is because we can only have even number of plates on the adjustable dumbbell, right? That's the only reason, right? To qualify as a function, the first thing is that every input or every x value should have only and only one y value, okay? Every x value should be having only and only one output, one y value. Let's see, does it qualify? So 0, 5, and then there's no other y value repeating with 0, good. 2, 15, there's no other y value repeating with 2, good. 4, 25, there's no other y value repeating with 4, right? So every x value has exactly one y value. You see this? See this? Right? So every x value has only and only one y value. Okay? So this qualifies as a function. Okay, let me write it down. Let me write it in blue. Qualifies as a function. Okay, because let me write it down here. Because every x value has no more than one y value, right? For it to qualify as a function. Okay, every x value has no more than one y value. And let me tell you this, we can call this we call this as a one-to-one function, because I'll tell you for now. Remember, this is a 1-to-1 function. Okay, the reason is that in this, every y value even has only one x value. Now there are functions we're going to see in the future where a y value can have more than one x value. For example, this 15 could also be having an x value of 2 and minus 2. That is also a function, right? Because it does not it does not basically um, violate the condition of every x value having one y value. Okay, but one to one can only be called if every y value also has only one x value. Now mind you that y values can have more than one x value. It will still be called as a function. I hope that's clear. So let's come to the next example and let's again analyze whether we can call the upcoming example as a function or not. So let's say we have x squared plus y squared is equal to 4. Okay, it's always interesting to visualize it graphically. So okay, so let's draw our diagram. It's gonna look like this. Let's graphically draw it. Okay, not the perfect one, but just to give you an idea. now here's the thing. Let's analyze something. Let's say if I take the value of x as 1, okay, you see the value of y is a bit above -2, and then here a bit below 2, right? Let's say if I'm taking x as 1, okay, so let's calculate it. Basically this is plus √3. Let me write it in red. And minus √3, right? Plus √3 and minus √3. Now let me write it in a nice way, right? Now here's the thing. One x value is having two y values. So therefore we cannot call this a function. Although there are some x values with only one y value, but it does not matter. Even if one x value turns out to have more than one y value, you cannot call that a function. So not a function, okay, violates violates the condition of x value having only one y value. Okay guys, I think that's it for today. So this video is more than enough to understand a function, and see you guys in the next video. Thank you.